Hello, Algebra 2 students. This is your first I'm absent, so you get left with a video. I know you're all excited. A couple things I want to remind you. Number one, make sure that you have earbuds or headphones with you at all times because you never know when I'm going to be absent, like today. Two, for this particular assignment, the substitute should have handed out another packet, looks similar to the one from yesterday, but it starts with number 20, and it probably has handwritten at the top, Algebra 2, 831-17. So make sure the substitute has given you that paper first. Also, this program for this video is made on an app called EduCreations. I try to put these videos also up on YouTube, so if you are having any technical difficulties and you have your phone, you can watch it on YouTube as well. So, before you start on this packet, I'm going to have you do it in parts. The first thing I want to do is I want to review types of functions. We talked about this the other day. You're going to know from the shape of a graph, and you're also going to learn how to determine from an equation what a graph is. Its name, or if I give you an equation, you will have a general sense of what the graph should look like. So, the first graph is a general linear equation. Linear equations, those straight line functions, were the ones whose equations were of the form y equals mx plus b. There are some special cases of linear functions. The next one being a special case called the constant function. The constant function is always a horizontal line, and the equation is always y equals a number. I use n for number. It could be y equals 3 or y equals -5. Another special case of linear functions, I don't know if we mentioned this the other day, is called the identity function. And it's the linear equation y equals x, specifically y equals 1x. The reason it's called an identity is because any number you plug in for x, the same number comes out for y. For example, if you were to make a table like you learned in Algebra 1, if you plug in -3 for x, -3 comes out for y. Or if you plug in 0 for x, 0 comes out for y. Or if you plug in 5 for x, 5 comes out for y. This is not true of these general linear equations. Not that you can't get an equation where the output is the same as the input, but it wouldn't be true for every ordered pair. The next function is called a quadratic. Quadratic functions are the ones that have an x squared in them. The shape of the graph is always a U. We have a special name for it. It's called the parabola. Anytime you have a graph that's shaped like a V, we call it an absolute value function. The absolute value function is always an equation that has absolute value bars in it. The next function is called the square root function. And just like absolute value function, the square root function is an equation that has a square root in it. The next type of graph that we'll be spending more time on in another unit is, this is a cubic function, although we're going to talk about these things called polynomials. This is a word you ran across in Algebra 1. And any polynomial will be an equation that has x raised to a power. So when x is squared, it's quadratic. When x is cubed, we call it cubic. Any other exponent bigger than that, we don't have a name for it. So if you have y equals x to the 4th, we just call it a 4th degree polynomial. Or if it's x to the 5th, we call it a 5th degree polynomial. The one that I did not pre-prepare. There's one more. It's called a rational function, and again, we will spend more time on this on another day. Rational functions have a very special looking graph, and they're very particular because they're equations that have fractions where the input variable is in the denominator instead of just in the numerator. Although rational functions can have x's in the numerators, if there's an x in the denominator of the fraction, the graph will be shaped like this. So what I need you to do right now is stop the video, and on that packet, I want you to do number 20 to 23. All you have to do is identify the type of function. 21, 22, 23, you should read them because one of the things I want you to do is to start looking for patterns on how you can read a problem and determine the type of graph that it might involve. So stop, do those problems, and then start again. To do the next page of the packet, we're going to talk about something called the zeros of a function. This is fancy talk for find the x-intercept. You already know how to find the x-intercept. Remember, x-intercept is where the graph crosses or touches. I want to be very, very particular here. Is where the graph touches or crosses the x-axis. And so the special name we have for it is a zero. One of the things you're going to find out here in Algebra 2 is we have several words that all mean the same thing. So finding the zeros and finding the x-intercepts are asking you to do the same thing. So remember, when you find an x-intercept, you got to know which axis is the x one. One of the most common mistakes students make is they accidentally flip-flop x and y. So in this first example here, the x-intercept would be this point here. So in order to figure out the point, I'm just going to count the tick marks, and it turns out it's the second tick mark, so it's at x is 2. So the x-intercept is at x equals 2. Another way of writing this is as an ordered pair, 2, 0. Remember, in an ordered pair, x comes first. There's no rule that says how many x-intercepts you can have. In another unit, when we talk about those things called polynomials, we're going to find out that there are equations that cross the x-axis many times. So in this second problem, in this quadratic equation, I want you to notice that there are two places where the graph hits the x-axis. It hits here. This is at x equals -2, or otherwise known as -2, 0. And right here, which is at x is 3, or 3, 0. Now these two particular graphs, I want you to notice I put big dots on the y-axis as well. I did that on purpose because we want to make sure that you know the difference between the x-axis and the y-axis. So I want you to stop at this point in time, and I want you to do problem number 26 and 27. To do 27, I know it says to graph it. Well, in order to graph it, why don't you go use Desmos? So go use Desmos. The nice thing about Desmos is that you're going to be able to click where it hits the x-axis, and you'll very quickly find how to find the x and y intercepts. So stop, do that now, and then when you're done, start the video again. I'm going to do a little revisiting of problem number 27 because I had you use Desmos and just graph it and then click. You could find the x-intercept and y-intercept. When you click on the point, Desmos pops up the ordered pair for you, which is really nice, but you're not going to be able to do that on a test. So we need another way of finding an x and y intercept. So we can actually find them algebraically. Here's how to do it. For the equation 2x plus 6y equals -12, to find the x-intercept, one of the things I wanted you to notice was in the previous problem, in the ordered pair, the x-intercept always had y was 0. So it was always a number, comma, 0. All you have to do is plug in 0 for y. Well, when you plug in 0, what's 6 times 0? It's 0. What ends up happening is you just make y disappear, and I mean the whole thing. And then you solve this equation for x. And you find out that negative 12 divided by 2 is negative 6. And then to find the y-intercept is always going to be the ordered pair 0, comma, y. That means x is 0. So to find the y-intercept, you plug in 0 for x, but 2 times 0 is 0. So it basically makes that term go away. So you're left with 6y equals negative 12. Divide by 6, and you find out that y is negative 2. So now that I know the x and y intercepts, if I wanted to graph this, all I have to do is put a dot on 2, 3, 4, 5. Negative 6 on the x-axis, and on negative 2 on the y-axis, and there's my line. It's another way of graphing a linear equation other than putting it in slope-intercept form. Remember, slope-intercept form was y equals mx plus b. So now just look back at number 27 real fast and see if the x and y intercept makes sense based off of how we did this problem algebraically. Take a moment to do that. The next thing that we're going to review is maximum minimums. We've already addressed this. Some graphs have high points and low points. In other words, if the graph changes direction, so we like to read graphs from left to right, like we read a book. So I want you, if you're reading this from left to right, the graph is going up as we read it from left to right. The reason it's going up is because the y values are getting bigger. That's how that works on the y-axis. Up is bigger and down is smaller. And then it stops. And as you continue going from left to right, now the graph is going down. Anytime the graph changes direction, it's going to have a maximum or minimum. Which one is it? Well, if the point is at the top of the graph, it's a maximum. If it's at the bottom of the graph, it's a minimum. So this particular graph would have a maximum. And the maximum occurs at the ordered pair, let's see, 1, 2, 3, 4. It looks like 5, 1, 2, 3. So I'm going to say it's at 5, comma 3. Other graphs that change direction, because not all graphs change direction. Absolute value functions. Anytime you have a graph that has a v, it will have a maximum or minimum. I will go back to square root function. A square root function will also have a maximum or minimum. It'll have a top or a bottom. But there are graphs that don't have a maximum or minimum. Linear functions, those straight line graphs, whether they be horizontal or diagonal, have no minimum or maximum. Because those graphs don't change direction. They continue in the same direction forever. So what I'd like you to do right now is on problem number 28, you'll notice I crossed off part of the instructions. That's because we haven't done that yet. I want to do that on a different day. For today, what I'd like you to do, in Desmos, graph 28A, B, and C, and then use the cursor to click on the maximum or minimum and identify the ordered pair. It also says identify the x and y intercepts. Please be sure to read all the instructions. One of the things that happened yesterday is people were answering one part of the question but not the other. So I realize that for some people that seems to be a little discombobulating. I'll try to remember that in the future and try to do a better job of separating instructions so that you don't miss anything. But just graph them, click, and then write on your paper, the maximum is at this ordered pair, or the minimum is at this ordered pair. When you're done with number 28, you can go to 29, and you're only going to answer parts A through G. I crossed off H, I, and J. So you're going to finish now with 28 and 29. Please make sure that you're also talking to the people in your pod and checking your answers and helping each other out, because I'm not there to answer your questions today. When you're done, turn the paper into the substitute with your name on it. If you have any additional questions, please make sure to email me. Have a great rest of your day.